Alright, I want to talk for a little bit here about the second derivative test. And so you can see I've written up here some given information. I've given you information that f prime of 3 is equal to 0, and that f double prime of 3 is less than 0. So, now, it's kind of strange how I've just given this information and so forth. You know, usually within a problem you might be given certain elements of this and have to find out other elements. But the idea that this will lead us to is to finding what is happening on the graph of f at x equals 3 and really determining whether there's a relative min or relative max at x equals 3. Okay, on the graph of f. I want to make sure we're clear on the graph of f. So, anyways, what we know here is that f prime of 3 is equal to 0. F prime is the derivative, which tells us about slope. So we know that the slope of f is 0 at x equals 3. So again, this right here tells us that the slope of f, the graph of f, is 0 at x equals 3. Okay? So that's what that is telling us. F double prime of 3 is less than 0. Well, f double prime tells us about concavity. So if f double prime of 3 is less than 0, that means that f is concave down at x equals 3. So this tells us that f is concave down at x equals 3. So what we have, we don't know exactly what the graph looks like, but we know at x equals 3 that the graph is concave down. So I'm just kind of drawing something that's concave down, downward facing, and at x equals 3 has a slope of 0. So you can see at the kind of the peak up here, there's a slope of 0. Okay? So like right here is a slope of 0. So this is kind of my example of x equals 3. And again, I don't know what the graph of f looks like at all. I'm kind of drawing just a sample thing, which, you know, I know of what I know. I know that at x equals 3 the slope is equal to 0, and I know the graph is concave down. Okay? So from those bits of information, I can determine that there's a relative maximum at x equals 3. So I could say, you know, here there's a relative max at x equals 3. And, you know, the strange thing is this isn't really a problem necessarily, but I'm just trying to, you know, help you that if you ever came up with a problem where you maybe were given this type of information or somehow how to find it, you could use this information to determine whether there's a relative min or max. So, so again, from this information I could determine that there's a relative max at x equals 3, and if you, in a certain problem, again this one isn't really much of a problem, and you had to justify, you could say since, and the justification for this would be since f prime of 3 is equal to 0, and f double prime of 3 is less than 0. That would be my justification. Okay, using the second derivative test. Now, you know, I could have, you know, changed one element here. I could have said, for instance, from the start that this is greater than 0, okay, which would have indicated that f is concave up at x equals 3. So a concave up graph might look like this. Slope is 0 right here, okay? So we would be dealing with then a relative min. Okay, so if this were the case versus what I just had a second ago, there would be a relative min at x equals 3, and that would happen since f prime of 3 is equal to 0 and f double prime of 3 is greater than 0.